Okay, so I welcome each and every one of you to this section. It's supposed to be a continuation from the last section, the last presentation, the last period section we had on Printf, where I tried to reveal the secrets of Printf. I mean, for us to rewrite such a function, it's important we know what the function does, its nature, what it looks like, you know, its capacity, so that when we build our own function, we'll give it uh, the same capacity or similar capacity, you know, either completely or partially, which is very important. I wish I watched. I wish I saw the other video. I can't remember exactly. I can't recall exactly where I stopped, but I'll just continue. I just continue. So I have an app here, Git Bash, this terminal app, and I want to open two of it, right? So there's no big magic here. I'm opening two of it, so I'm opening another one here. I'm going to put it at the right side of one at the left, one at the right of my screen. And so what I want to do is I want to use one as an editor and use the other one as a terminal. I mean, there are two terminals, so any change I make here, you see the other way. For example, if I cd into this place where I usually work, I think it's here. Let me see what is in POD. Okay, so let me use okay, I think I should rather make a new directory and call it printf. Yeah. So I've made a new directory called printf. If I go to this other terminal, right, to cd into this same place, top one directory, you find out that the directory that I made called printf is here. I said that to say that any change I make in the left will reflect in the right, because the terminals are connected to the same computer system. So there is no big deal about what I'm doing now. But I'm going to turn one into an editor just by opening my editor. I don't want to close it throughout this presentation. And this one is just going to serve as the terminal. There's no magic here. Okay, so I'm going to cd into printf. So I'm going to make sure I'm in the same place this way as well. All right, so I'm going to clear the screen. And here I'm going to call my editor. I think I want to begin with a file name. Let's have a main.c file. Yeah, it will be our main. What should I call it? Yeah, it will be easy for testing. Be testing out printf that is working, like if that is working like normal printf that is giving us the result we want. Okay, so you know how we roll. I don't want to have plenty header files in my. I don't want to have plenty include. So I'm going to have them all in my header file, right? I don't want to. So I'll just include my header file. My header file will be, let me call it header.h. I can choose to call my header file anything I want to call it, right? But header.h makes sense. It makes sense. Okay, so if I save this, the file should appear here. Sorry, the file should appear on this terminal. If I cut into it, I should have the same thing. Just to emphasize that there is no magic happening. Left side is my editor, the right side is my terminal. All right, let's roll. Okay, we're gonna have a header file called header.h. I'm gonna be toggling between files. So let me create a new file called header.h. Header.h. This is called include guard. You must have encountered it several times. I know we have people from several different cohorts in this call. So we might need this. In fact, I don't know whether we need this because we're not allowed. I mean, let me say not allowed. You if you want to code your own printf, you don't want to use any member of the family of printf. We have puts, we have putzka, we have um somebody help me now. The printf itself.
Printf.
Yeah, we have f puts. We have which one again? F put C. We have put C. I mean, there are several of them. They all have the work of printing. They have their own style. Some take two arguments, some take more than. You don't want to use any of these. So you want to create your own file that is capable of printing things with standard output. So I don't think we need this std.h. But if we need it, we'll convert it. What am I even doing? It's not even the first thing to do. I'm supposed to use the include guard, sorry. If not defined. If and if header. If I decide to call this in something else, yeah, it will still work. But it's important to follow convention. Okay. Please, if you're not talking, you can mute your mic. But quickly unmute when you want to talk. I'm hearing some sound there. Co-host, help me mute that mic. Thank you. I like to have it like this. Header .h. All right. So inside here now, I want to have the header files. And standard library header files. Should I call it C standard library header files? I'm trying to make the codes as arranged as could be. I'm using Windows, so we can't do with Betty here. By the way, Betty should be sleeping by now. Betty is not part of this class. Betty should be very much asleep. So I want to have include. Please, I'm here to learn as well. If I'm making any mistake, come attention. So I'm not sure we need stdio, but I'm sure we need standard arg. Let's see arg. We might need we might need this guy because we need to produce to be able to stream something to the standard output since you're not using any of those guys from the stdio. How did I know we need that guy? I know because I by reason of practice I have a Linux system is dead now. I want to access the manual. Okay, I have Vagrant. I'm gonna open another terminal. And this guy is for Vagrant, right? So I'm gonna put this one in the middle here. So that I can access the Linux terminal and Linux manual and all of those things that are in the Linux environment, just to show us certain things, because I want to not just code and see you and let you see it work. I want you to observe how bit by bit the things came to be and started working. Okay, so I'm going to move into the environment where I have my Vagrant file, and I'm going to call Vagrant up, just in case you don't know what Vagrant is. Vagrant gives me that environment, similar environment that your sandbox gives you. And if you don't know what sandbox is, I'm trying to imagine someone that's in LAX seeing this video. So if you don't know what sandbox is, I'm talking about an environment, a terminal that looks like a Linux environment. I guess you that Linux environment, you have the same things you have in a Linux computer. While using the terminal, you have them there, very similar things. Yeah. So while it's coming up, let me continue here. When it comes up, I'm going to show you why I called this guy. We don't just know what we should put. We know by reason of practice, we want to use something. So, okay, this thing will be here. Would I include this? I think there might be more that we need. I remember now as we make progress, I'll add more. So I'm going to use here I'm going to add my function prototypes here. I don't have anyone yet, so I'm going to be adding them as we make progress. If you have knowledge of writing functions, kudos. It's easier for you to understand what is happening here. If you have knowledge of Variadic function, I may not touch switch case. Switch case makes it easy, but I'm trying to make sure that this thing is very much easier. I want to avoid some things like function pointers, double pointer. Let me see how well I can avoid that. I wish I had enough time to prepare for this. I wish, but nonetheless, we are here. So we'll do something. Okay, Vagrant is up. Vagrant SSH. Watch this now. It will leave my computer now. This particular terminal will leave my computer. and go to another place. To go to another computer inside my computer. You know. All right, here we are. You can see that the prompt has changed. Look at the prompt background at Ubuntu Focal, whereas the prompt on my computer will show Topman at TMA Worldwide. You know, see, it shows you that I'm in a different environment. This one is in my computer. Anything I do here will be in my computer. Anything I do on this computer, even this file I'm creating, we can see it from my this guy. You can see from my file explorer. You can see them from here. But anything I do here is in another different environment. So how did I include that in unit std? Is because I know that I'm going to be using this guy, right? And using this guy um, um, implies that you must use this header file. This guy, right, is a function that is defined in this header file. So why am I calling right? Well, if you've paid attention to the content of underscore put car, call it put car. I think put car is more accurate because that car stands for character. Okay. If you paid attention to what is contained in its function definition, you would know that this function right was used here. This function right was used there. So I want to use it to be able to bring something out, stream something out of the standard output. You know, and that's why I added it there. That's by the way. Let's make progress. Okay, so now let's start working. Let's start working. Where do we start from here? Where do we go from here? How many files do we have here? So I have header Emacs have started. What's that command now to make this guy not create duplicate copies? The command has left my head. All right. I have header.h. I have main.c. Main.c, like I said, is going to be the file I'm going to use in testing my function so that is working. So let's go. Let me create printf now. Printf.c. It will be on. Let me call it my printf. My printf.c. All right, here we go. Like I said, I don't want to do too much. I don't want to have too much other file here. So I'm going to move into this. What's that file again? .c and get this thing that I have here. Copy it and go and paste it here in this file. All right. So what do I want to do in my printf files? First of all, we should know the prototype, right? The prototype. But I'm aware that printf returns integer, so I can choose the prototype myself. It returns integer. Okay, we'll see if our Linux environment here. Let's look at printf. Man, is it man 2 or man 1 now? Printf. Printf. All right. So printf formats and print data. It formats data and it prints data. All right. And so print what? Let me look for the what's happening here? Come on. Is that all? There should be more. There should be more. I'm looking for the prototype. Who knows I can get it? All right. Okay, see what we want to achieve right now. There's fprintf. Let's forget about that. Let's talk about printf. Now you've seen why we call this this header file each time we want to use printf, or these siblings, fprintf, and what have you. You may not have used this one before, but at least you know printf. Now this is its prototype. I think I want to copy it. Let me use this one, because if you leave me, I can choose one person's name in this PLD and give it as a name of the prototype. You know, I need us to follow very well. So here we go. Int printf, but the name of my function is not printf now because I can't name any. It's illegal to name any function after an already defined function in the C library. So I want to call this my printf. My printf. Now it's quite interesting that this guy returns integer. Quite interesting. I didn't know this until it was time to do that printf uh, um, project. I didn't know this. No, come on, Carry. I'm adding. I should have done that in the main file, not here. Okay, now let's find out what I mean by it returns integer. When we say return, return is return. Return is like okay, you're going on an errand. Get me back this report. I'm interested in this report. You know, you're going to play. You're going to see a football match. I want to know the highest goal scorer. Return to me the highest goal scorer. You know, let's say I'm one of the sponsors of the football and I want to give a special award to, let's say, the best referee, and I say I'm interested in referees this time. Return to me the best referees. Those are the best referees. So among everything that is there, because I have said I need names of best referees, that's what they will give me. So that after they've given the general award, I will not pick. I will not say from top man we have awards for the best referees. You know, I say go and do this business, return the profit, hold the money, or return. I mean, so that's return value for you. So why do we always return zero from main program? Is because zero stands for success. Zero is what you want to return if the program was successful. You know, the program was successful. So this is the main program, right? So it's going to be int main void. Come on, I'll do that. I'm so used to adding the void that I must remember you can work without the void. Now let's check the return value of printf. So by storing it inside a variable of type int. So let's call it arrow value. So I've declared the variable here. I'll go down and say arrow value assign to arrow value the return value of printf. So if I go and say, let's just print something, let us say go try and we're done. Now after that I want to see, okay, because I'm using this, because of what I'm doing here, let me add this guy. Because I've used printf here, let me add this other guy before I cause wahala. I will soon I may remove it as we make progress. If we get to the point of, if we finish this our function, I won't need it. I don't think I need it. So stdio dot h. Okay, making progress. So I want to now say printf. I want to print what is saved inside the r value. I say r value is r value is %g, and the variable I want to pass there as a second argument will of course be r value. If you've seen the first video, it should be flowing here. And this is our main program, so we want to return something. We have to return integer, because what we return here, the data type that we return here is indicated by this guy here. So we must return int. So we are saying that if this program is successful, return 0, which is a sign, a signal, a feedback, you know, that is required to announce that the program ran successfully well. So I think that's it. I want to have a new line here. This is Windows, so it will naturally add a new line. As a matter of fact, if I add a new line, it will become the whole line. But let me be disciplined. I validate this. So now see what happens. I didn't just call printf code try directly. I save it in a variable, but it will still do what it does. But I have cached the return value inside here. Printf itself has return value. Let's find out what it returns. So I'm going to go here and compile the program I just wrote. Just compile this main. Come on, stop creating duplicates. Who knows the command to stop duplicate copies? I used to have all this stuff. Where did I keep them? All right, so I'm taking all the duplicate copies off. So I want to. This is my file. We'll call this. What should I call it now? Okay, somebody give me a name. Let me hear somebody's voice. You'll be hearing my voice. Let's give me a name to call this file. Nice name, oh. How funny one. Hello. That's a miss. That's a miss.
Many, many, many,
Many.
many.
The many did not. The many did not sound well in my ear. It is okay. Let's do something that will work now. There is many. It's okay. Let's take many. All right. Many is ready. This is Windows, so it will add .exe, main.exe, except I rename it. As I don't want many.exe, I want it to be called many. I don't know why you said many. All right, so I want to run the file many. All right, code try. Oh, sorry, I did not add new line in my line 8. Code try. So I need to add a new line here. I will save it. I will recompile it.
Sorry to take you back, Coach.
Okay.
Yeah. Where did you say 9? What is in code tribe? Where did 9 come from?
What?
Well, you didn't define anything to be 9.
9. Okay,
You
just
said
calm
code
down.
tribe value is
Calm down.
9.
Don't worry. Just listen. Just follow.
Okay.
Thank you. All right. Many. What is happening now? Why is my new line not displaying?
Because it's a many.x. I mean, many.ex.
Oh, thank you very much. You must be a Windows user. So the new one is saved the mini.es. Okay. Okay. I started with Windows, but I'm no more a Windows user. So let's run our refi that has a new line printed now. Why you see? Do I still have many here? What did I remove? Thank God I see it here. Okay, nice one. So I'm running. Let me clear my screen so you see at the top. I'm running this executable file again, main.exe, and that's it. So it printed code tribe and tells that arrow value is 10. Arrow value is 10. I added a new line. It became 10. It was 9 before. This guy is just counting what is here. C
Sir,
is
we
1.
can't see your screen.
Excuse me. Can someone else confirm? Someone else should confirm.
You can see your screen. Your screen.
Okay. Well, you need to refresh your network and join. I think it's from your end. Okay. So you see CODE is 4, T5, R 6. I've told you that you should do 2 things for me when you have a question. Get your computer system, put it by you in front of you. That thing you want to ask, try it on your computer system, whether you get it, find the answer. That is one. Number 2, allow me to land. I may answer your question in the course of presenting. So if I land and then you've tried it and still didn't find the answer, then you can ask this question. Otherwise, the question will become distraction. Did you get that? Thank you very much.
Yes, I get it.
Okay, so it counted CODE, TRYBE. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. That was how I counted 9 before. And when I added the new line character, it then counted 10. That means because this guy, that's this guy now. Let me show you. Printf, my print. Okay, this guy has the capacity to return integer type. Note that it return integers, and the integer return is the number of characters that it printed. The number of characters that it printed. The number of characters that it printed. That's what it returns. So no big magic here. what I just did was I called printf. Let me off this line. This line is likened to just, this line would do from here. We perform what it just performed without this line. Without this alpha equal to, it will perform its function. But the difference is that I didn't just let it perform its function. I let it save its return value into this place. That's what happens when you assign a function to a variable. It saves its return value inside the variable. So this line 8 is what printed this first line you're seeing here, code tribe, with the new line. And then this other line now, we use it to print what has been saved inside our value in line 8. So having noted that, it shouldn't now become strange when you are asked to have your own printf, your emulation of printf to return integer. Even putchar returns integer. Now you may have seen something like this. I think let me define putchar in another. Watch this. I want to print a character to I want to print the character without printf, without any member of that family. So I just go write for me. Let me put something inside the variable here. Car name. Okay, let me save my name inside this place. Or I'll save my name in full. So Topman or GK. There we go. Now I want to access that place with the function, write function. So I go write. This is the file descriptor. Let me take you back to that place just in case you so Q, I did it there before, mount2, right? So it takes 3 arguments. One is the file descriptor, another one is the buffer, like the temporary storage. Then another one is the count. The count. How many characters do you want to write? How many characters from this buffer do you want to write to this file descriptor? It's usually an integer. Numbers represent different file descriptor. If what I'm saying sounds like a grammar, please don't worry. But just know that, just have in mind that 0, not return value. I'm not talking about return value right now. Okay, don't mix them up. Let me put a comment here, up here. So 0, of course, you should know that this is not the standard way of putting comments in. See, I just put in full screen mode. Come on. 0 is for standard std in, standard input. 1 is for std out, standard output, and 2 is for stdl, standard error. So when we did 1 here, pass 1 as the first file descriptor, we are saying this thing we are asking you to print out now, stream it to the standard output. So that's us even saying print out this thing. That's one way of doing without all these guys from this stdio family. So I say, okay, let me count now. I want to print only top man. So I go 1, 2, 3, 4, 5, 6. All right. So I print from the buffer name. Go into name and print. And what I want you to print is just 6 characters from there. Semicolon. And the statement. Let's see whether this will work. Okay. I think Windows will add a new line for me. So let me save and go and run. If there's no error, our program should work well. That's main.c. So let's run again. Yeah, the one that gave me the name many. I don't know what gave you the inspiration. GCC something many. No complaint. Excuse me. Okay. So many.exe. Look at that. Look at on the screen. I'll say right from this buffer. Keep it up, man. So you can see that we already have a means of bringing something out to the standard output. So So because I said stop at 6, it picks the first six character, and nothing. It has no business with the other characters. That is how that underscore putka is implemented. That's how it is implemented. So they go here and they tell it to pick only one character. As well as they tell it to pick only one character. And if I do this now, it will pick only T. Let's see. Save. Compile again. Run. Look at only T. So this is us trying to. We know that putka, printf, putka gives only one character at a time. Printf gives any format you want. It formats it and prints it out. Why put just prints only a string and gives you a new line by default. I told you, if you've read something about these things, it becomes easier to flow in this class. It becomes easier. But nonetheless, just pay attention. You sure learn something new. You sure learn something. And you'll be a better you. Yeah. So watch carefully and attentively. Now, we don't want to have one of the functions help us to reuse a particular to perform a particular action repeatedly without writing the function. So I don't want to be write this, write that every time. So what do? I'll go and define it inside another block of code, like you may have experienced, you may have seen before. Most of us have seen before. Let's just underscore putka and they ask you to return something that has this form. Okay. Here we go. So I want to define that in another. Now, by the way, if I do this, say C equals, if I declare another variable here called C, and say C equals putka, let's say putka A. The question now becomes, what will C be? What will C be? You want to ask another problem. What will C be? If we check the value of C, what will be stored in C now? Yeah. A will be stored in C. Okay. Anyone wants to try again?
1.
Do we all agree with her?
1.
Did you say 1?
Yeah.
All right. So you find out, right? I just that's something about doing. It's when you're doing that you're actually learning, not when you're listening. Now I'm doing the teaching, but you're the one to do the learning, and you learn by doing. Right, so you find out what it is. Okay. Now let's go and define underscore putka because we need it. We need it. So I am going to create a file. In fact, I don't want to use underscore putka. Let me call it my own. Let me make some guy. Let me call it put chair without the A. So C. You can see what is happening down on my left side. Down. That's where I'm creating the new file. I think. Let me. Okay, it's fine. That's C. All right. I think I want to go back here and copy this line 1, and of course paste it here. So we're good. It has to return integer because the real putka returns integer. My own is putka. Let me take some spelling so I don't. And it takes only one argument. Ziba first to use Z. I can call it anything. It's my right. So it doesn't do much. It just returns. To the file descriptor, the standard output, whatever is contained. Notice that I did not use ampersand when I did the right one. I was working with string. Here I'm working with a single character. I'm working with a single, so you have to put the ampersand because you are trying to access the address. I was working with a string, and a string is naturally a pointer to the first member to index 0. Also, I did not use that ampersand, and now I'm using it. Give me only one character. This kind does not work exactly like putka in a way because putka will not tolerate it if you give it more than one character, it will throw. Hello, can you help me with the mic, please?
Hello, you are using Z as a variable.
Thank you very much. Thank you very much. Ah, I was thinking of only you. You're talking in three voices. Thank you. Thank you for paying attention. Okay, where was I? I was saying something. All right. This is cool. Just know that I don't care about Betty right now. Okay. So my return value is just not in the, it's not, the whole thing is not in the bracket. It's not enclosing brackets. It's intentional. So let's find out whether our underscore putcar is working. And of course, every function I define must be contained in the header file. Mine is header.h, so I'll define one function. Let's have it here with a semicolon. So that is the end of the statement. All right. So let's confirm whether our own putchar is working. Remember I said that this file main.c is for testing things. Also test as well things are working. So let's try to print. Someone should omit and tell me if I want to print the letter A from my name. How do I do that? I want to use my function to print the letter A from my name. How do I do that? Because if I give
name for
what?
name for putchar name for between brackets.
Name like this. Okay. Did you say 4?
Between brackets.
Okay, like this.
Yeah.
Okay, let's try that. Thank you. If my putcher is working, then it should be able to as well print a new line character here. So let's see. So it should print A and a new line character if this is correct. I'm going to compile that file again. Okay. There's an error. Reference to putcar
I
on the
don't think
file.
we had.
Okay,
I don't think we
okay.
had a prototype to either file yet.
No, that's not it. That's not it.
You should add the
Error.
putchar in GCC.
Thank you very
Okay,
much.
okay.
So I'm not referencing it as expected. So we are still working with our many, right? Many exe. Come on, don't do that. Many. Is many gone? I don't have many again. If I'm making guy with something else, test. All right, so you compiled now that error. I want to clear this screen, and I want to run. As if there are tests that exe. So I want to run it now. Let's see. So it's working. It printed A. Note, I mean, if you anyway, T is at position 0. O is at position 1. P is at position 2. M is at position 3. And A is at position 4. That's how we managed to get this. And here we go. Let's make progress. And then so our put guy is working. Then let me now. I think I want to storm my printf. I want to start my printf. I want to be able to have it do what this guy is doing here. So let me declare another variable here and call it r value 2. Yeah, so I'll be using one to check printf. The main printf. I'll be using the other one to check our own printf. So I'll go here and say let me put a comment here. Using the printf. Okay. It's not by making printf. So I'm using printf or using the C standard printf function. And yeah, let me copy this and have it pasted here. So I'll say can you please just not like my course looking the uniform, come on. Alright, so using the user defined my printf function. Okay, I want to have this line in the same place here because it belongs to this place. Oh yeah, we're making progress. So you're going to be having a new line here under this place to check how our printf works, and I like it being beautifully formatted. So I'm going to do this printf. Let me just say put. This is just to see what is happening, because if you don't print to the standard output, you will not see what is happening. So I'll do integer or something like this. So using printf, and then I will go like this and like this, and I'll have this line copied. I'll have it pasted here as well.
You're missing the closing quote.
Closing quote. Oh, thank you very much. Thank you very much. So using my printf okay, then we're making progress. We are making progress. We are making progress. All right, now you know that I may not go through Variadic function. I'm trying to resist temptation. We don't have plenty of time to do that. But if you know Variadic function, then flow with this. If you don't know, you want to go and pay some attention to it, so when you come back, you flow better. So I may okay. I'm not going into my printf. I'm going to write my printf right now. Have it. Do I have a printf.c here? No much. Okay, it's my printf. My printf.c. All right. Now I have this. Now you know that this is a Variadic function, because in fact, I found out from experience that when we do, let's say, if we have the prototype like this, let's say we want to add variable numbers of arguments, and we'll say int n and do comma and do dot, put this ellipse here. This n is not really doing much here. It's not really. It's just there for us for us to be able to control our for loop. Yes, I tried to do without it. We did some task where we had to add separate or something like this. I think we had the constant character, and we'll call it separator or delimiter. And then we had an integer here still stating how many numbers. Now this guy is not really stating how many numbers. That's what I think. He has to be corrected. He's not really stating how many numbers that should be here. We are the one that made it to state how many numbers. How? When we did that for loop and said I for I less than n, that was when we stated that it should our function should pay attention to the number of argument passed such that if we pass 5 here, then it is expecting 5 arguments in this dot dot dot. If we write 7 here, it is expecting 7 arguments. If there are more, it will not attend to the others. If there are less, it will attend to the ones. Just the way I printed 6 characters earlier on. It was top man Paul DK, but he printed only top man because it had to attend to only top man. That's what this guy. That's not its natural function. We are the one that is giving that function when we create that for loop inside our file. Okay. Now, I did that because I started asking myself, okay, this guy is here now. In printf, we don't use to state how many numbers. We don't use to state how many numbers that we, how many numbers of argument we need. So how do I want to ask myself, how do I now iterate safely? But then this is a string. Printf has its first argument is usually a string, always a string. Then each other argument, I'm tempted to say, can be anything. Can be a variable is just a container. It could be a string, it could be character, it could be floats, it could be integers. So, having done that, let's see what we can do. Let's see how much we can do with this. Okay, so I want to first put something to the standard output. I want to be able to put something to the standard output. So, let me have, okay. You know that this guy is as good as a data type that is contained in the header file std arg, which I have inside. Come on, what's happening? Emacs, respect yourself. Which I have inside this place already at line 5. std arg. Okay. Now values, I'm declaring a variable of values, and it will represent the list of, this list here, list of all the arguments. So let me call it, what should I call it? Let me call it args, popular args. Okay, I can choose to call it anything, right? And then I want to tell it start. I want to initialize it right now. I say start. Of course, the first argument here will be the list, of the list. And the second argument will be where this guy is starting from. Where are you starting? Because this is a pointer to the next member on the list. Right? Am I correct? No, I think it's arg that points to the next member of the list. Yeah, that's the order. Someone wants to say something?
I think it should be format.
Oh, thank you. Very correct. So format takes this position because that's the last thing you see before the ellipse. So next thing I want to do is to be able to print out what we have inside the list, inside format. But then you know that printf treats this guy. Let me do this. Is it main.c, right? Printf has special respect for this guy. This guy is special. I said that in the from my video. I don't want to go through that again. Okay, maybe I should just skip it. But just know that, but you remember that this guy called percentage is special. You don't just put it in printf and expect it to print out. If you want to put percentage sign, you have to put 2 of it. So when you put this, printf is waiting to see the next thing that comes after it. If it's C, it becomes a format specifier for character. And so when you're building your own printf, you want to take that into cognizance. You want to pay attention to that. So I'll now say if okay, I need an integer to iterate through the first argument, which of course is a string, as you can see. So it has to be unsigned because it must be positive. So I'll say I'm tired of using I. I'll say Dutch. So I'll now say if let it be equal to 0, if format h is not equal to this guy, if not percentage, this guy, then print. That means, in other words, if it's this guy, skip. If it's not this guy, go ahead and I think I need a for loop. Yeah, I need to loop through that guy. So let me say for what I want to use hedge. So hedge is already initialized here. I'll just put semicolon and pass. Let me put a space so you see it clearly. And the condition, what will be the condition now? As long as format hedge, as long as format hedge is not equal to the null byte. This is a good condition to check. I think this is the best condition to use now. Okay. Then here now I want to begin my for loop. So if format is not percentage, if any particular character passed into that first string that our printf takes is not this guy, just go ahead and print them out. So print okay, print. Oh, I don't mean I'm not supposed to have anything. It's put put char because we are using original functions all through. So put char me that particular now what the particular element in that index that is not I think I'm correct here. That is not equal to percentage. Okay. So after doing that, of course, I want to return integer. I want to be able to count how many I printed. Right. So I will have another guy here. Let me call this one R value or R val. R value is fine. Return value. Let me initialize it to 0. And so I will come here and say, after doing that, R value should increment. So R value will be the new value of R value will be R value plus 1. Whatever R value is. R value is 0. When this loop runs the first time, it becomes 0 plus 1. When it runs the second time, it becomes 1 plus 1. When it runs the second time, it becomes 2 plus 1. That's it. And then I want to also increment because h is what we're using to loop through the iterate through the whatever is passed in the string, the individual characters in the string until we hit the null byte. Okay, so you're making progress. But then we want to be able to state what happens now if it's a percentage. But let's take it bit by bit. Let's go and see whether this one is working first. Saving this. You're supposed to be used one. Okay.
Sorry.
Yes.
Why we don't put the increment of R value inside the if? Why we put it outside?
Inside the loop. Okay, it will still work. Fine, it will still work. There is no. So let me take this one off.
No, the other increment of R value.
R value. It's because we want to be able to count. Want to be able to count how many times, right? Want to return the integer, and that integer we are counting how many times this puts printed.
Yes. But we should make it inside the if.
Inside the if.
Yeah.
Inside the if. Are you sure? Because this guy is working with the for loop, but not with the if.
Yes.
Okay. I think you have a point. You should
Can you hear me? Your voice is gone.
Yes, I can hear you.
Hello, top man. We can't hear you again. 15 naira. I'll collect you.
Topman, if you can hear us, I think your phone has disconnected from the meeting, so you are no more being heard. Well, let me put a call through. Don't worry, he will join us soon. I just wanted him with a call. So he didn't know that his phone has disconnected from the meeting. He was using the phone for audio and the system for presenting.
Hello? Hello?
Yeah, we can hear you now. We can hear you.
Hello.
Thank you. Ah, very embarrassing. So my phone is connected from the meeting. It's okay. Let's continue. Since the phone want to make guy, let me do without it now. Let me do without it. Whether you can hear me from here. I didn't know my phone. I was using the mic from the phone because my voice tends to be clearer there. But then that chose to embarrass me by hiding my voice. All right. Okay. So here I'm using the variable out to save to see whether my printf will print this string. No, to see whether my printf will return the int, and to see whether you'll be able to do what this guy did here. Now let's find out. And I want to let's have. I think let me have the boolean here. No, it's fine. It's fine. Okay. What am I missing? Nothing. Because our printf is not really working like the other printf yet. We are not printing integers yet, right? We are not able to use. We have not implemented the percentage format specifier yet. So because of that, I'll use printf in this line, in line 18 for now, until we're able to implement ours. So I'll go r value 2 is percentage d, and of course a new line. And the second argument will of course be r value 2. If there's no error in this code, there's no bug, it should work. It should also whether our printf is working like the other printf yet in terms of printing string passed to it. There's an error here. Where's this error coming from? Is that not out? Oh,
You didn't add the
We
function.
add
okay.
the myprintf inside the header.
What? All right, thank you.
Adding the function.
Thank you. And then put these are the three we used so far. Yeah. I think I
Did
can
we
save
add
this.
You can use the
did
while
we add
statement.
the
You can use
prototype of my function inside the header?
I don't remember. Let me check. You see, I don't have it here. Thank you for calling my attention to that. Let me get it. Okay, so let's add it here. We're good.
So Instead of manually typing the C files, you can use the worker to grab all the .c files.
Yeah, I thought about it. Well, but okay, fine. I'm using that. If it was a Linux system, I would have used the Makefile. No, Makefile is not even needed here. I thought about the probability of having a C file that is not yet in use and then attracting unnecessary errors. So let me even have this guy saved. This guy is not saved yet. Put car is not saved yet. So sure. Right. Okay, so let's roll. I'm going to leave this here in this interface, and I'm going to compile now. And of course, use our same. No. What does the menu.c disappear when I want to use it? Test. Okay. Errors again. And let's see whether we have been able to emulate printf to an extent. So I'm going to run that file, test.exe. Here's what we get. This is what the printf is doing. Using printf, we got this. Using my printf, we got this. Whoa, this is like step one. Something to celebrate. So we move one step further. Now let's consider the unique thing about printf. One unique thing about printf is we are taking it step by step. So printf is able to recognize percentage. It's able to treat percentage symbol as a like a special thing. And this thing is not looking as clean as I want it to be. What can I put in the middle here? Because it's going to get I get crowded. So let me have something here. Something like this. Because that is a waste of printf. So let me. And then I'll not use this last line again because put will put a new line, right? Am I correct? Sorry, I just like how to be look as beautiful as it can look. Okay, fine. I think I don't want to turn again. Don't mind me. All right, so it's clear now. Using printf, what you have up there, and using my printf, what you have down there. So you see, we have successfully returned the value. We still have the value that we wanted, And then let's now go back to implement spatial recognition. Let's treat the format specifier specially. Whoa. Okay, so how do we do that now? Next thing we want to do is to check what follows format specifier, because we've been able to. I didn't do something. Please, let's check with that. Let's check how this guy treats the format specifier first. How he treats format specifier. If I add, let's see, format specifier somewhere in between code and tribe, see what it does. Compile, error. I'm going to clear the screen so you see clearly. I'm going to run it again. He didn't care about that percentage. He skipped it. We've been able to ask it to skip it. Don't treat it like an ordinary character. Skip it. Okay, but then you know that in printf, when you put that thing twice, the second one is supposed to print. So it's getting more complex. It's getting more complex. And now the reason for that line, just to show you, the reason that line is printing is because of, I mean, if we didn't have this if statement here, if we didn't have this if statement, and let's see, I comment this line off, enter this line, enter this line, and then indent these to be in this for loop directly, and then I compile, there's no error, and I run the file again. See, now it prints the percentage that is between the code and the tribe. It prints it. Right. Haven't demonstrated that, let's bring our code back to how it is before, how it was before. Lines indented. I don't know what I did. All right. Now, let's try to recognize, let's try to make it print a character when C follows. So let's check. Let's check. So else, if, I mean, there's a more efficient way to implement this, but I think this will make us understand, will be more uh, more all inclusive than using things like switch case. Switch case is quite simple, it makes it easier. But someone who does not know how well to use if else just might be confused if you use switch case. That's what I think anyway. But if you think it's more efficient, if you think it's better, we use it. I mean, I'm looking at how well I could communicate these things to the one watching now, the one in this call. If you think, if you have a better suggestion, I'm open. I'm open. So now I want to check if the things that follow that follows the format specifier, we're using H, right? H plus 1. If H plus 1 is C, and know that it is specifier for character, what do we do at this point? If H plus 1 is C, then it is most likely that the first argument or the second argument, let me say the first argument after the string, yeah, the first argument after the string would have been a character or a variable containing a character. I hope I'm really communicating this thing. I mean to say that if you have anything printf like this, and you have whatever it is here, and you have percentage C, there is no way to pass percentage C here without passing either a character or a variable containing the character. So, and that variable containing the character has to be the guy that var will be pointing to. Var will be pointing to it. So we want to attack that member now and go and print out what is there. And that's what I'm trying to do here on line 17. So I say if the guy that follows percentage C, that follows the percentage symbol is C, then we want you to go and print what is, I mean, we are assuming that what is following must be a character. We want you to go and print what is inside there. And of course, we are not using any standard library function. So we use our guy that is capable of printing one character. And for this time, it is attacking the next member on the list. I'm using the word attacking. It's going for the next member on the list. And how do we do that? First, of course, it takes two arguments. One is the list. The other one is the data type you're expecting. Right? Hey, something funny happened here. Something funny happened here. I was wondering why car did not work and int was working. Honestly, I wish I had no time to prepare for this class. I wish I had no time. I've been so busy. But let's just do what we can do. So for arg, name of our list is what again? Args. And we want to print. I think see what will happen. I want to print car, right? So do this if that's the matter. And this comment was just to do some demos. So I'm taking them, take it off. And then I think this is enough. if this blog is good. So come on, don't do that. The next thing you want to do is skip that C and not print it. Skip the C and don't print it. If I don't skip the C, it will do what we ask it to do, but it will still print what is in C. Let me show what I mean. What I mean is, let's go to the main function. Why is this party? Why are you embarrassing me now? I thought I had enough party. Main.c. All right, so let's declare a variable here of type car. So I'll say car. I want you to have only letter A. Car letter equals A. So variable is just container, so we can choose to pass the argument straight or indirectly using a variable. So let's say %C man. The C man. Do the same thing here. %C. Oh God, why now? My battery is not lasting again. So we have to pass the variable here, of course, later. And here too. Passing the arguments later. I think if everything is okay, there's no bug in this code. It should run. Let's compare. Let's compile again. What's that? Okay, fine. I expected that, but because the battery is running low, let me just quickly go and correct what that is looking for. I will not talk about it now. So it's to change this thing to int. Very funny. You want car, but let me change it to int.
parentheses.
Hey, don't stop me.
Parentheses.
All right.
The close parentheses.
What?
Input char missing closed parentheses. Yes, 17. Line 17.
Line 17. I didn't get that. I didn't get what you said.
Like the
What please? The close bracket.
Yeah.
Thank you. All right, so our code is running now. I'm too not happy about this battery right now. Okay. Now a C man is still printing the C. He printed the A, but still printing the C. The reason is because we didn't skip it. And to skip it, I'll do this. I'll say we either go +2 or do another what now inside here. An instruction here that you should increment
H++.
Thank you. H++, so that it does not print out C again. And that's it. So our value is now you can see that our value will not increment again because it's now inside this block. But if you bring it out from that place, it will give us wrong value now until you bring it out from that place. So we will get it out so that whatever be the condition, after running through that if condition, it comes out and still increments the return value I want to give out. Okay, so let's compare this again. I run it again. All right, so a man. This is how far our printf is simulating the standard library printf. I'm thinking I should end here right now. This is not a class I want to present to the phone. I think I should end here. Man, I'm really sorry. Like, it's like my battery has started being funny. I thought my system was very charged. But let me see how far I can go. How much further I can go. But at this point, any question? What we've done so far? If there's no question, I'll quickly implement. Let's see whether I can quickly implement that as a string. Now, if what follows the percentage is S, percentage symbol is X, this is what we want to do. It's going to be a string, and this time you want to be able to iterate through that string, because var will just point you to the whole thing, but you want to be able to iterate through it, go inside and do something inside, and that makes it necessary for us to define another function that will do that for us. So I'll call this one put string. What that mean? What happened here? But not of something from this code. What is happening here? What is happening here now? Okay. So that's what happens when you're under pressure. Now I'm under pressure to deliver this thing before the battery goes off. What is my strength? No. What is missing? Okay. Right. Okay. So if it's
It's gone, battery gone.
Yeah, his battery is gone right now. I think at this point you might have to call it the day. That would be like the end of part 2 of the Printf series. Hopefully we are going to continue this some other day. So I'm not sure if Topman will be joining us back, but let's just wait for like a few minutes. Okay, he's back with his phone.
Hello. sorry about that. Sorry. I don't know. Just don't know. I mean, we will have to reschedule and consider from where we stop. But I think the video will still be valuable. Yeah, the video will still be valuable. I think something similar happened in that part 1.
Yeah, exactly. Something similar. So we have to like stop and continue. So this will be part 2, then the next one will be part 3. So watch out.
What I don't want is for the battery to take another long time. My brother, Elias is not giving somebody British face. Okay, well, what you've seen so far, let me challenge you. Try and go and implement a function that will iterate through that next member now, because you're assuming that if there's a percentage s, then the next member in the list of variable arguments will be a string. It must be a string or a variable containing a string. So we need a function that will iterate through that string, that will visit each member of that string one by one. So that function the put char created cannot do that. So maybe we have to use the put char as a hint. We have to use the put char inside of that function to create one that will naturally enter into that string and bring every member out and print them out. So try whether you can do it. Try. I like to see you post in your groups. Just post and say this is what I tried. And thank you so much for coming out. I don't know. I will reschedule this and I will let you know, announce as well. If you're not in Code Tribe, do it to join us. Let us. Okay, just the link for intended members. But if you can identify your cohorts and you're not in Code Tribe, we will give you the link to your section in Code Tribe. Code Tribe is a big community in LAX where we make pair learning real. And we push ourselves. And then if you don't subscribe to our YouTube channel, please do well to subscribe to our YouTube channel. Do well to subscribe. I'm going to post a link now. Thank you so much, Heritage. Thank you, Mr. Bedu. Thank you. So that's the YouTube channel for Code Tribe. Put mine now. Post.
Just a sec. I want to grab the link.
All right. So please just do well to subscribe, please. Let's learn together. Let's learn
and
together.
then install.
And if you see videos that you like,
Okay, there
you
it
like,
is. As you can
like
see
it.
it. So I
Let's know you like
open
them.
it.
You have good comments for us.
Now yes,
Put your
go there. So
comments. Thank you,
disregard
Kelechi.
these things, okay?
Thank you.
So the first thing you want to do is pick.
Thank you. So
upgrade.
you can see that as hard as these things are, they can be simplified. They can be simplified. Don't be scared. You can do it. You can do it. It's just to give you time it needs. And thank you, it's okay. Thank you. I hope to see more of you. Aja, thank you.
Yeah,
Thank you.
please, Aja